Now, welcome to probably one of the first things that you're going to learn now, which is new, you did not do in grade 10, that is angle of inclination. Now, I need you guys to remember some of the things we discussed in trigonometry, okay? So if you've got a line on a plane, okay, on a horizontal plane to be particular, here's my x-axis, we need to be actually considerate of the fact that there is an angle theta, which that line is actually being inclined on. And if you will remember again with me, we discussed measuring angles, positive angles and negative angles. In this case, we are discussing positive angles, okay? So we are moving in that direction. So in the case where the gradient is positive, and I hope you guys can see that this gradient is indeed positive. I hope you can see that because the line is going this way, all right? In the case where the gradient is positive, we can see we are having theta as acute. The angle of inclination is acute, in other words, meaning it will be between 0 and 90. If the gradient is negative in this case here, then what's going to happen is that, remember, we are measuring a positive angle, so don't be tempted to come down here. You are actually thinking of this angle here, theta. And this angle, you can see then clearly, it is actually obtuse, okay? Meaning it is greater than 90 degrees, but less than 180 degrees. Now, what we're gonna use here, we're gonna use a nice, interesting fact. The fact that the tangent of this angle, what is interesting is it is actually equal to the gradient. That's the fact. I don't really have much time to show the derivation or the proof of this, but you can probably go ahead and explore this and see what happens if you have got a point there with some particular coordinates, of course, provided that the point also passes through the line, and see what happens if you find the tan of theta. And the reason we work with tan, I'm sure you can think with me, it is very simple because tan is actually not x over y over x. And if you think of the points on a line, a point on a line is represented in terms of x and y. And so that is why it's easy to actually determine that. All right, now we are going to have instances where you are given a question and you have no clue, you have probably only one point and you have no clue what the gradient is, or you are probably given an inclination, an angle of inclination, and you don't know what the gradient is. In that case, guys, we're gonna have to use this equation actually to find the gradient. If you are given an angle, you just punch the tan of that angle, the ratio will be your gradient. Otherwise, guys, what you can do is, in a case where you are supposed to find the angle of inclination, you know that theta will be arctan. We have spoken about this when we solved general solution. Remember when we did the issue of what is this reference angle, right? Yes. Now coming here, it's going to be essentially the same thing, but here, since we have an obtuse case, guys, you are still going to have tan theta equals to m. But now the caution here is that when you look for your theta, yes, you're gonna have arctan of m, but you must add 180. What this does is that it actually eliminates you from thinking that this is the angle that you are working with. I hope we got that together. Note that m here is negative. So you are adding 180 because remember, tan of a negative angle is negative. So you are actually having a negative gradient here. So you're gonna have actually a negative angle here plus 180. So it will rectify and give you a correct positive obtuse angle that you're looking for. Of course, in a case of a line that is parallel to the x-axis, there's no angle. The angle is actually 0. In a case where the angle is parallel to the y-axis, we know you've got a 90-degree angle there, and tan of 90 is undefined. Again, using the knowledge which we have already established. Maybe I could end this video by looking at an example. So the example here says, find the inclination of the line PQ, right, if P has the coordinates square root of 3 and 1 and Q 0 and 0. In other words, Q is at the origin. So the first thing, obviously, guys, that we've got to do is to find the gradient. And if we're going to find the gradient, we know is change in y over change in x. So this is going to be 1 minus 0 over square root of 3 minus 0. And this is just 1 over square root of 3. And then to find the inclination, we know tan theta is equal to m. We have just found m. So theta is actually arctan, right, of what? 1 over root 3. And I hope you know your special angles. This is 30 degrees. Simple as that. Of course, I'll leave you to try this and see. Given P is minus 3 and 8, Q 1 and 4, what is theta? Go for it. Let's have a chat on WhatsApp and see what you've done. Cheers.